Hello and welcome to part 1 of step 23. Step 23 says I can apply properties of parallelograms. So in part 1 we're going to talk all about parallelograms and rectangles. In part 2 we are going to talk about rhombi and squares. So in this step in the book we're sticking with chapter 6 just like in step 22. The sections are 2, 4, and 5. So I also shared with you guys a sheet called Unit 5 Vocabulary. So I'm going to pull that up, and I've already typed out what I want you to put in your first few boxes. So in the first one, we've already covered sum of interior angles, which is our n minus 2 times 180, where n is the number of sides. The sum of exterior angles is always 360, and we could add in here always, regardless of number of sides. Okay. The new thing so if you need to pause this video because I go too fast, go ahead and pause it, and then you can write it. And I'm not going to go through all of these. But you can also, the first thing we're going to talk about is parallelograms. So feel free to go ahead and write all these down so that you have them before I go over them. So if you need to pause the video now, I'm going to switch back to the notes. The notes have some nice visuals, especially for the parallelogram ones. So just trying to make this video as concise as possible. All right, so properties of parallelograms. So parallelograms, you know some parallelograms. One would be a square is a parallelogram, a rectangle is a parallelogram, a rhombus, if you know what that is, that's another name for a diamond. So one thing is that the opposite sides are congruent. Okay, just like in any rectangle or square, the opposite sides have the exact same length. Also, the opposite angles are congruent. So when you have to go all the way across the triangle, so M and K would be the same, J and L would be the same. Consecutive angles, okay, remember if things are consecutive, they're right next to each other. Okay, so this would be like J and M, M and L, L and K, K and J. And remember, supplementary means add to 180 degrees. If a parallelogram has one right angle, then all the angles are right. So one right angle, all 4 angles are the same. So this would create either a rectangle or a square for you. So we're just going to jump right into an example. There's a lot in this video, so I want to keep moving so it doesn't get to be like a half-hour video. That would be kind of long. So let's label this as we go. Angle A is 55. That's hard to see. Maybe green would work. So angle A is 55. AB, so between A and B is 2.5 feet. And BC is 1 foot. Okay, so we want to find DC. So DC is the bottom piece of our parallelogram. In a parallelogram, if you think of like a rectangle as a good parallelogram, the opposite sides are congruent. So DC will have the same measurement as the side across from it, which is AB. So if AB is 2.5, DC is 2.5. Okay. For angle, so we can label that if we want, 2.5 feet. For angle B, so the only angle we know is angle A. So angle A and angle B, if these two angles were opposite, meaning across from each other, like angle A and angle C, they would be the same. But A and B are next to each other. They're consecutive. So these two are actually supplementary. So angle A and angle B, oh, not D, B are supplementary to each other, which means that they should add to 180 degrees. So if we take 180 and we subtract away the 55 we've already used, we would get 125. Yes, 125. So the measure of angle B is 125, and then I can label that. Okay, when we go to look at angle C, we can do a couple different ways. So angle C, if we follow with the trend that we found angle B with, those again would be supplementary because they're right next to each other, or the opposite angles are equal to each other. So angle A, measure of angle A, is equal to the measure of angle C. And it gave us that A was 55, so the measure of angle C is 55. Okay, so hopefully that was a nice little refresher on kind of parallelograms and what they look like. We'll save number 1 for class. So the one thing about parallelograms is if we draw their diagonals, meaning these lines are going to go through the middle of our picture, and they're going to connect non-consecutive vertices. So they're going to go from A, in this picture, A to C would be a diagonal, and B to D would be a diagonal. Okay, if we have a parallelogram, the diagonals bisect each other, meaning they split each other exactly in half. Okay, so we would have AP would be congruent to PC, and DP would be congruent to PB. That's not to say that all 4 pieces that we've now created are the same, but the 2 pieces of the same diagonal are the same. Okay, second thing, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. Okay, so the 2 pieces that we've created are now congruent to each other. They're just kind of rotated around each other. Okay, so let's take a look at example 2. So we know QRST is a parallelogram. Okay, this time we want to find X. So I'm going to go ahead and highlight X. It's right here. Okay, so it's measuring, it's on the outside of the parallelogram. It's measuring the side of QT. Okay, the sides of a parallelogram, the opposite sides are equal to each other. So this one would go with the opposite side of RS. So QT is actually equal to RS because they're opposite sides. So 5x is equal to 27. Obviously, that's not a perfect division. So x, if I divide by 5, x is equal to 5.4. All right, next we want to find y. So let's see, y is sitting here and here. So if we wanted to go back and mark, we would have this side is congruent to this side. Those are our blues. Okay, so now our greens, it's kind of hard to see how it's labeled. I wish it was kind of tilted a little bit. But 2y minus 5 is actually measuring TP, and y plus 4 is measuring PR. So it's sitting on that diagonal. Well, if we scroll back up, we just learned a couple of things about our diagonals. And one important thing is that the diagonals bisect each other. Okay, so these 2 pieces that we've created are actually equal to each other. We could say that TP is equal to PR. So 2y minus 5 is equal to y plus 4. Okay, I could subtract y from both sides and get y minus 5 equals 4. Then add 5 and y would be equal to 9. Okay, last but not least, we're looking at z. So I'm going to look, okay, z is right here. Okay, so now what we're looking at is the angles opposite of 3z. So 3z is part of angle S, but it's not the whole thing. So if we look across from it and that opposite angle of Q, we have two options. We have a 95 and a 33. So I'm going to show you something real fast. So if this is our parallelogram, the big things about a parallelogram are that the opposite sides are congruent to each other and they're also parallel. So if I look at QR and TS, those are actually parallel to each other. And then I could draw this nice transversal. So once again, we're going back to our angles, okay? The two angles that get caught in the pockets of this Z, hopefully you're thinking, oh, well, those are alternate interior angles, okay? So angle, what's that? TSQ, which was our 3x, is actually equal to RQS. Which was 33. Okay, remember alternate interiors are congruent. I can divide both sides by 3x, or x, why did I put x? Jeez. Z, let's try that again. Z should be 11. Okay, and that is example 2. All right, we'll skip those, save them for later. All right, so in this one, so we're talking about coordinate geometry. So we're talking about our x and our y values. We're looking at a coordinate plane, a small graph. I'm not going to have you graph this because it's probably easier to just compute it than to actually draw the picture. So if we just think about, if we drew this picture, remember when we draw a parallelogram, let's just say this, it doesn't matter, we don't care about the coordinates or anything. When we name a parallelogram or any polygon, we start at a side and then we rotate around. So I'm going to start at F. I always start in the upper left and rotate clockwise. So if that's F, then G either has to go down or across. Then H, then J. So you're always rotating all the way around, either clockwise or counterclockwise. You may not say this as, please do not label one as F, G, H, J. Okay? That's not legal. You're not allowed to jump across. Okay? So let's just imagine that this is our parallelogram. Okay? If we drew our diagonals, oh wow, that's not good. We drew our diagonals. So all we know about parallelograms is their diagonal, well, not all that we know, but about their diagonals specifically. Their diagonals bisect each other. Okay, so if I just said, let's say this point here is just M, okay? M should be exactly in the middle of F and H and exactly in the middle of G to J. So if you remember, when we find the middle of a segment, if we have coordinates, okay, so let's start with FH. So our coordinates of F would be -2. Coordinate of H would be +2. And remember, we always add them together. So -2 + 2 would be 0/2. which is just 0. And then let's find our y coordinate. So F would be 4. Again, we're still adding. H would be -3. So 4 plus -3 is a +1 over 2. And we're just going to put this as a decimal, which would be 0.5. Okay, and just for the sake of practicing, let's make sure that it works out for our other diagonal, which would be G to J. So our x-coordinate of G is 3. And then remember, we're always adding. The x-coordinate of J would be -3 over 2. 3 plus a -3 would be 0. Divided by 2, still 0. And then our y coordinates would be G is 5, J is -4 over 2, so we would still have 1/2 or 0.5. So our final answer would be 0, 0.5 or 0, 1/2. Okay, so this is just a quick tidbit just about quadrilaterals. So if we know that we have a quadrilateral, we can always assume things about the opposite sides, the opposite angles, consecutive angles, all that kind of stuff. But we can also go in reverse. This is kind of a nice to know thing, not necessarily a need to know for now. So if we were able to show that both pairs of opposite sides are parallel, then it's a parallelogram. Congruent, all that kind of stuff would all work. So now we're going to move on to rectangles. So I'm going to switch back to the note cards. Okay, so here's our test for parallelograms. We're going to skip that. So let's just focus on rectangle here. So a rectangle is a parallelogram, so it's still following the fact that the opposite sides are parallel and congruent, opposite angles are congruent, consecutive or supplementary, diagonals bisect each other. The only two new things about a rectangle specifically is that all the angles are right and that the diagonals are actually equal to each other. So in that last problem we were doing, the two diagonals that we found have to be equal to each other as well as bisecting each other. Okay, so if you need more time to write this down, go ahead and pause the video, but I'm going to go ahead and move on. So that's all this is explaining it, okay? This is the big piece, okay? For rectangles, diagonals are congruent. New property compared to what we've already been doing. Okay, so we have the Parks and Wildlife Organization plans to add 2 diagonal walk paths as shown. PS is 180 meters. Okay, and P to R, whole piece here, is 200 meters. Okay, so we want to find QT. So we're just looking for, I guess I could pick a different color. This piece right here, just QT. So QT is obviously part of one of our diagonals. Okay, so let's talk about our diagonals for a second. We just established that they're congruent to each other. Okay, so this says that PR is actually equal to QS. So if PR is 200, then QS is also 200 meters. Okay? The next thing we want to talk about is a rectangle is still a parallelogram. Okay, so all of our rules still apply when we're talking about a parallelogram, which we did this a couple problems ago. A parallelogram's diagonals, just a general parallelogram, they actually bisect each other. Okay, which means that PT is equal to TR and QT is equal to TS. Okay, so remember our goal is just to find QT, which we now have that in one of our equations. Okay, if QS is being bisected, that means that each piece is equal to each other. So if each piece is equal, if we know the whole thing is 200, we can divide it by 2. So really, QT is QS divided by 2, which is 200 divided by 2, so it would be 100 meters, would be our final answer. Okay, same sort of idea if TS is 120, and now we want to find PR. If TS is 120, we need to double it to get to the entire length. So we could do QS is 2 times TS, which would be 2 times 120, which is 240. And then PR is that same length. QS is equal to PR, so PR is 240. All right, we're going to skip that one for now. The angles. I believe this is our last example. Yes, last example, okay? So this time we're talking about a quadrilateral. It looks like a rectangle, but we're not going to, oh, it is a rectangle. It says that, Finish reading the question. Quadrilateral JKLM is a rectangle. So what we know about that is that opposite sides are congruent. All of our angles are 90-degree angles. Diagonals bisect each other. Diagonals are congruent to each other. For this one, we're going to talk about the angles. So for this, let's see, KJL. So remember, we're going to start at K, go over to J, and over to L. So this piece right in here is 2x plus 4. All right, and then JLK, so just that piece, is 7x plus 5. Okay, so we've labeled this. We need to find what x is. Please do not resort to saying, oh, 2x plus 4 should be equal to 90. It's not, because it's not all of j. It's just a sliver of j. Same thing for 7x plus 5. That's most of L, but it's not all of L, so we can't use that. But going back to what we covered in Unit 4, notice our diagonals are creating different triangles. So if I highlight my two angles that I was given with the x values, okay, and then I highlight angle K, I've created a nice triangle for ourselves. And we know the 3 angles of a triangle should add up to 180 degrees. So I could add together 2x plus 4 plus 90 plus 7x plus 5 is all equal to 180 degrees. So if I combine my x's, I get 9x plus 99. Okay, subtract 99, subtract 99. Would that be 81? Divide by 9, divide by 9. X is 9. And I only needed to find x, so I am finished. All right. So just want to talk about one last thing before we go. Just like how we can prove that parallelograms are actual parallelograms, we can do the same thing for rectangles. So the only extra step is that, in particular, diagonals of rectangles are congruent. So we could prove that the diagonals are congruent, and then therefore it had to be a rectangle. Okay, and that is part 1 of step 23.